Hi, today we are going to discuss addressing modes topic. So here what is an addressing mode? First of all, the addressing mode is nothing but the different ways in which the location of an operand is specified in an instruction are referred to as addressing modes. Nothing but the different ways in which the location. So in the CPU, so different locations are there. In that, an operands are going to be worked, so that operands is specified in an instruction are referred to as addressing modes, so that instructions are going to be referred to particular addressing modes. So there are different types of addressing modes we have. So let us we will discuss that addressing modes. So before that addressing modes, first of all we need to know that register transfer notations we need to know. So what are the register transfer notations we are going to follow? We are going to use that notation names and all we will discuss, and we will see some assembly language notations also. With that we will get to know what are the instructions or notations we are going to follow for that particular addressing mode in that assembly syntax we will discuss. So possible locations that may be involved in such transfers are memory locations, processor registers or registers in the IO systems. Most of the time we identify a location by a symbolic name standing for its hardware binary address. So for that, for example, names for the addresses of memory locations may be LOC, lock location. LOC is nothing but location, comma place, comma a, comma where to. So these are all the memory location notations. And processor register names may be R0, comma R1, comma R2 dash dash R5, like this. These are all the register notations, names, processor register names. And IO register names may be data in, out status, and so on. So these are all the some notations. So the contents of a location are denoted by placing square brackets around the names of the location, thus the expression. For example, R1 arrow mark LOC location. So the square bracket we are going to use here. So after that some assembly language notations also here we are going to use. So those are like move. So particular location we need to move. For example, for that register particular location we need to move. So we are going to use that notation called move. And add by adding that memory registers like R1, R2, R3, add. So move, add, and some operations called source, comma destination, and add and move, like these notations we are going to use. Load, add, store, and like this. So these are all the notations we are going to use for registers as well as assembly language notations. So for registers already we discussed that registers are called loc, location, place, a, comma variable 2, those are called memory locations. And processor registers names called R0, R1 dash R5, and IO register names like data in, out status, and assembly language notations like move, add, store, all this. So these are all some notations. With that we will make that addressing modes. So as we know that these data can be organized in a variety of ways. If we want to keep track of students names, for example, we can write them in a list. So if you want to keep track of students names, we can write them in a list. If we want to associate information with each name, nothing but adding that students names with that for example marks and mobile number. For example, to record telephone numbers or marks in various courses with different courses, we may organize the instructions in the form of a table. So for that student data we are going to place all that students information in the table. So in the same way, programmers also use some organizations called data structures. So programmers also use organizations called data structures to organize any. For example, to organize a student, we are going to use the information, we are going to use table, as well as for programmers they are going to organize called data structures to represent the form of to represent the data used in computations. For nothing but computation is nothing but manipulations. So these includes like lists and linked lists, comma arrays, comma queues and stacks, and all these so and so we are going to use for that programmers to organize the data by using data structures. So programmers are normally written in a high level language. We know that programmer can understand only high level language, programmer can write the code in high level language, but computer can understand only low level language. So for that, low level language is nothing but zeros and ones. So to convert from high level language to low level language, we need some language called assembly language. So that is called assembly language is nothing but the combination of high level language to and a low level language. So programmers are normally written in a high level language which enables the programmer to use constants like local and global variables, comma pointers and arrays. Like when translating a high level language program into assembly language, the compiler must be able to implement these constants using a facilities provided in the instruction set. Already we have seen that instructions called like move, add, store, like that instructions. So many instructions are there in that assembly language. So set of the computer in which the programmer will be run. So these assembly language instructions, with that using assembly language instructions only, so the local and global variables and pointers and arrays, so that it is going to be translate from high level language to low level language by using that assembly language notations. So the different ways in which the location of an operand. So here operand and operator. Operator is nothing but a symbol. Operand is called like a comma, b comma, c, like 1 2 3, those are all called operands. So operand is specified an instruction are referred to as addressing modes. So some addressing modes we are going to use. So here different types of addressing modes we have. Let us see that addressing modes table. So generic addressing modes table we have here. Different types of addressing mode names are there. That is, first one is immediate, second one is register, and third one is direct, and fourth one is indirect, next one is index, and next one is base with index and offset, and the next one is relative, and auto increment and auto decrement. So these are all the different addressing modes, and these are all assembler syntaxes. So assembly language syntaxes, and these are all called addressing functions. So by using this immediate address mode, so what that assembler syntax is going to be used and what the address function it is going to be performed. Let us see. First one is immediate address. So in this immediate address mode, so directly we can access that hash value. Value is nothing but operand is equal to directly value. Operand is equal to what? Value. Value is nothing but a signed number. Value is nothing but a signed number. And second one is a register. Register is nothing but, already I said that registers like R0, R1, R2, RI. So RI is nothing but register instructions. So RI is nothing but register instructions. EA equal to RI. Here EA is nothing but effective address. EA is nothing but effective address. Directly effective address is equal to register instruction. So next one is absolute, nothing but direct value. Direct is nothing but location. So assembly language instruction is syntax is what? Location, LOC, location. EA equal to LOC. And indirect is nothing but, so by indirect address is nothing but pointers. We are going to use like pointers like RI and LOC. For that EA equal to RI and EA equal to location. And the next one is index. We know that in that array we are going to use that indexes. By accessing that indexes only, the array value we are going to array value we are going to access. So index x of ri. So for that assembler syntax is x of ri. So ea equal to ri plus x. So base with the index, base value with index is ri comma rj, nothing but ea equal to ri plus rj. So base with index and offset also, x of offset is nothing but index with the offset also, x of ri comma rj, nothing but ea equal to ri plus rj plus x value. Directly we are going to use this base value with index and offset, nothing but ri plus rj plus x equal to effective address ea. Then next one is relative. Relative is nothing but x of pc. So ea equal to pc plus x. Relative address is nothing but, so auto increment is nothing but increasing the one value, ri plus register value ri plus. So assembly syntax is ri plus, ea equal to ri increment by ri. Auto decrement is nothing but minus ri, nothing but decreasing one value. So decrement of ri, ea equal to effective address is ri. So decrement the value and increment the address value and decrement the address value. So these are all the addressing modes. Thank you. Bye.